This is for Calculus Section 1.6, trig functions. But I want to warn you that this 1.6 is a very quick and dirty review of trigonometry, and you need to really remember much more trigonometry than is in 1.6. I put a couple other trig review videos on Edpuzzle, but if you're a little rusty on trig, you might want to do additional reviewing on your own. So here's our objectives: convert between radians and degrees. We're going to talk about period and even and odd functions. We're going to find the value of trig functions. We're going to talk about the graphs of trig functions and inverse trig functions. So this is where you're given the value of sine, cosine, tangent, and you're asked to find the angle. Example 1, we're going to go right into example 1, and it says find all of the trigonomic values of x if sine is -3/5 and tangent of x is less than 0. So let's just, I already drew in a little bit of reviews here. So this is a right triangle. This is our x, or it's often called theta. So this is the angle we're talking about. This is a right triangle. And so opposite the right triangle is our hypotenuse. The side that touches the angle that we're talking about is always our adjacent side, and the side opposite the angle we're talking about is our opposite. So remember, sine is opposite over hypotenuse. So remember, SOHCAHTOA, which I like to remember this as some old hippie caught another hippie tripping on acid. But that's not really appropriate for school, so I can't tell you that one. So you should remember SOHCAHTOA, and you probably shouldn't remember some old hippie caught another hippie tripping on acid. All right, so if the sine is opposite over hypotenuse, and they tell me the sine is -3/5, then I know my opposite side is -3 and my hypotenuse is 5. So if I recreated this triangle, and here's my x, I know my opposite side is -3 and my hypotenuse is 5. Now to find all 6 trigonomic functions, I need this other side. So this is Pythagorean theorem, which would say -3 squared plus, I don't know, we'll call this a, plus a squared equals 5 squared. So if I solve for a dot dot dot, I'm going to get a equals 4. So this side of my triangle is 4. Okay? So now picture this on the unit circle, where I have -3. So if I'm here, I would go over and down. So I would have, remember our angle, we always want to form with the x-axis. So this would be x. This would be my right angle. So my opposite side would be -3. Adjacent would be 4. Hypotenuse would be 5. And also in quadrant 3 over here, here's my right angle. This one would have, this side would be -4, this would be -3, and my hypotenuse would be 5. Your x, the angle you're talking about, is always going to be tucked up here in the corner with the x-axis. Okay, so now I have the sine. So my cosine would be adjacent over hypotenuse, which would be adjacent over hypotenuse would be 4/5. Okay, tangent is the same as sine over cosine, or opposite over adjacent. So opposite would be -3, adjacent would be 4. So -3/4. Cosecant, oops, I wrote cosine. Cosecant is the same as 1/sine. So my sine is negative 3 over 5, so that would be negative 5 over 3. Secant is the same as 1 over cosine. Here's my cosine, so cosecant would be 5 over 4. What am I missing? Cotangent would be adjacent over hypotenuse, or the reciprocal of my tangent, so that would be negative 4 over 3. So those are the other 6 trig identities and a little trig review. Once again, if any of this is not coming back to you quickly, you need to do some additional review of trig. So this is the standard form for when we talk about stretching and translating our function. So this one is a cosine. So this is all in your book also. This is on page 48. So the A that we're looking at here, and these are also labeled in your book. So the A is a vertical stretch, or a reflect about the x-axis. So this is a vertical stretch. Reflect about x-axis. So if A is negative, then you're flipped over the x-axis. And if the absolute value of A is greater than 1, then you have a stretch. Okay? The K here is a horizontal squeeze, or a reflection over the y-axis. So that is, if K is negative, then you would flip about the y-axis. And if the absolute value of K is greater than 1, then you have a shrink. Okay, C, these are easier. This is a horizontal shift. So this shifts it right and left. And remember, if it's a positive C, then it moves to the left. So this is kind of think the opposite. Positive C goes to the left, negative C goes to the right. And this is a vertical shift. And this up and down. Positive up, negative down. So this one you do not have to think opposite. Now I also want you to add to your notes this. Another way that it's often written is with this A, and I just use sine 2 pi over b x minus c plus d. So this one is kind of the in general nomenclature, not necessarily a trig function. This is more how it's written when we're talking about trig functions. So this absolute value of A is your amplitude. And remember, amplitude is the difference. So let me just sketch a quick graph here. Amplitude is the difference from the center of the graph, the distance to the maximum or to the minimum. So that's the amplitude. I like to think of it as how tall the graph is, but it's from the center to the max and center to the min. So 2 pi over the absolute value of b gives you the period, or you can think the absolute value of b is the period. But this is the 2 pi over b is how you calculate the period. So C is a horizontal, I'm going to abbreviate this, shift. These are kind of the same. And D is a vertical shift, so up and down. Okay, so let's look at this first example. First thing you're going to notice is I already graphed this because I didn't want to use the, I wanted to get it right and I didn't want to use the time in the video to do the graphing. But let's talk about where I found this. So this is the function we're looking at. And the first thing I want you to do is in the book, this is written slightly different. It's written as 3 cosine, and then we have a bracket, 2 x minus pi over 2, bracket, plus 1. So it more closely matches this here. Okay, and you can see if I multiplied this 2 by the x and 2 by the pi over 2, that's where this comes from. So we're asked to find period, domain, range, and draw the function. So let's start with period. Okay, so if you look at this, we said 2 pi over the absolute value of b, and the absolute value of b is the period. So if you think all of this, 2 pi over b, should be absolute value, in our equation is 2, so we have 2 pi over b is equal to 2 in our example. So what we want to do is solve for b. b is the period. So if I have two fractions with an equal in the middle, I like to cross multiply. So I get 2b equals 2 pi. Divide both sides by 2, and I get b equals pi. So pi is the period. Okay? So that means it will have one full cycle, if you want to think about it, between 0 and pi. So the purple graph I have here is your plain old cosine graph. This one I drew in pencil is our adjusted one. So cosine has a period of 2 pi. So it goes up, it goes down, and then back up between 0 and 2 pi. This new one is going to do its whole cycle between 0 and pi, so it's squeezed. All right, b is the domain. Well, cosine, even if you shift it all around, it's always going to have a domain of all real numbers. All x values can be on the graph of cosine. C is the range. For the regular cosine graph, your y values are always between 1 and -1. Okay, this one, we have some changes happening, and it's coming right here in our amplitude. So A is the amplitude, and in this case, 3 is the amplitude. So instead of going from 1 to -1, it's going to go from 3 to -3. However, if you look here, we're also shifted up 1, right? D is a vertical shift, so this is shifted up 1. So if it normally goes, picture it going from -3 to 3, and then I shift it up 1, it's going to go -2 to 4. So my range is going to be this interval from -2 to 4. And if you look at how I graphed it, I have -2 down here, that's the bottom of my graph, and 4 is the top of my graph. Okay, so regular cosine goes from 1 to -1. This one has an amplitude of 3, so that would be +3 to -3, but then I shifted the whole thing up because of that +1 on the end. So that means my range is -2 to 4. And then D says graph it. So here's everything kind of all put together. So I have one period between 0, here's how my graph is. This is pi over 2, pi, 3 pi over 2, 2 pi. So between 0 and pi, I have a full cycle here. So that's my period happening between 0 and pi. I already talked about my amplitude and my range going from -2 to 4. And I think that about covers all of it. Look at the example in the book if you need a little more explanation on that. So this is domain and range. So for cosine, it's going to be all real numbers for your domain. For sine, it's going to be all real numbers for your domain. For tan, x cannot be equal to pi over 2, right? It's undefined. Remember, tangent is the same as sine over cosine, so we can't have a 0 in our denominator. Cosine is 0 at pi over 2, so x cannot be equal to pi over 2. So x is not equal to pi over 2, and then remember tangent, I'm just going to quickly put a tangent graph under here. Remember, tangent graph does this. So pi over 2, it's undefined. And then it keeps going. So I want to represent my domain saying it can't be equal to pi over 2, but it can be all these other x values. So how we want to write that is x cannot equal pi over 2 plus pi times the integer n. Okay, so that's all of those pi over 2 plus 2 times pi plus 3 times pi plus 4 times pi. And then secant is going to be the same. X cannot equal pi over 2 plus pi times n. This just represents an integer. And then cosecant, remember cosecant is 1 over sine. Secant is 1 over cosine. So cosine is 0 at pi over 2. Sine is 0 at pi. So this x cannot equal pi times n. And cotangent is cosine over sine. So that's going to have the same domain as this. X cannot equal pi times n. Okay, range. You want to think about, for sine and cosine, the y values go from -1 to 1. That's going to be -1 to 1. Tangent goes up and down forever. So this is negative infinity to positive infinity. Secant, let's look at secant again. So here's secant. It starts at 1 and then it goes up forever. And then it starts at -1 and it goes down forever. Cosecant does a similar thing. So the range for secant, it goes from negative infinity to -1. That together with, the symbol means union, right? Together with 1 to infinity. So this is starts at 1, goes up forever, starts at -1, goes down forever. Both of those together represent all of the y values. Sine is going to be cosecant is going to be the same. So I'm just going to put these quotation marks. These are the same, so you want to copy those. And cotangent is going to be all real numbers or negative infinity, the interval, negative infinity to positive infinity. You could say all real numbers here also. Okay? All right, couple more examples here. Now this is find the measure of cosine inverse, so this is an inverse function, of -0.5, so ½. In degree and radians, no calculator. Now you might want to review these restricted domains. It's on page 50 and 51 in your book. They do a pretty nice job showing you it graphically. So I would review that. This is how I like to remember these. So remember, to find an inverse, the function has to be 1 to 1. So these functions are not 1 to 1 because they fail the horizontal line test. But if we restrict the domain, then we can find the function. And the restricted domain yields ranges that look like this. So cosine and 1 over cosine always go from 0 to pi. Sine and tangent are like the right side of the unit circle, which is -pi over 2 to +pi over 2. But again, might want to review these. So here they're saying this is an inverse function, so I want to think of that restricted domain and range. So cosine is going to be my y values are going to be between 0 and pi, or the top half of this unit circle. So when I'm finding the angles where I have -1/2, I just want to think between 0 and pi. Now this has no calculator, so I want to picture a unit circle. And remember, it's cosine, comma sine. So I want to think, where is cosine negative? So not going to be here, it's going to be here, would have a negative cosine, and here. But because I'm just doing between 0 and pi, I only have to worry about this quadrant 3. And where does that happen? That happens right here at 120 degrees, or 2 pi over 3. And this coordinate point here is negative 1/2, comma, square root of 3 over 2. So the answer here is 120 degrees, or 2 pi over 3. And there's only going to be one, because we just want to look between 0 and pi. Okay, example 4. So this said no calculator. This, you could probably use your calculator. You would probably need to. This is between 0 and pi over 2. How many solutions do you expect to have? So remember, the coordinate points are cosine and sine. Sine is positive, so y is positive in quadrant 1 and in quadrant 3. So we should have 2. So if I do this in the calculator, I get x equals 0.7754. So that would be in quadrant 1, and then the other value would be pi minus 0.7754, which would equal 2.3662. Right, so you can think about here and here. Here's my x. Here's my x. So this angle would be 0.7754, and this angle would be pi minus 0.7754. All right, and then what about this? This is tangent. This is from negative infinity to positive infinity. So, picture those tangent graphs, right? They do this forever. It's a really, really bad sketch, but you get the idea. So how many solutions should I have? Well, I should have an infinite number. So if I do this on the calculator, I get x equals negative 1.107. That's about, by the way, approximately negative 63 degrees. But then because they're saying between negative infinity and positive infinity, I gotta include all those angles. So I'm going to say plus pi times n, or it's often written k is another variable they use to represent that integer. So k times pi, pi times n, either one of those. And remember, we're finding the angles, so when I say on my calculator, that's when we use our tan inverse. So I'm doing second tan of negative 2. Oh, I don't know what mode I'm in here. I'm in degree mode because I got the negative 63. And so I probably should be in radian mode for calculus class. So let's change that. Okay, now let's try it again. So let's do tan inverse of negative 2. And there, I think I pressed something wrong there. Got negative 63. Tan inverse, negative 2. There we go. I don't know what was wrong. Oh, I didn't do inverse the first time. I just did tan. So don't make that mistake. So tan inverse of negative 2. There's my radian answer. Calculus, we always want to be in radians. All right, so that is your very quick trig review.